So, today we're looking at the legendary floating bridge of Ram Setu. And this brings up a huge question, one that people have been debating for centuries. Was this a divine miracle, a myth, or was it an incredible masterpiece of ancient engineering? And at the very heart of this entire mystery is a single baffling image, a rock that just floats. It seems to defy the laws of physics, right? But does it really? To get to the bottom of this, we have to start with the legend itself. Okay, so according to the ancient epic, the Ramayana, the story goes that Lord Rama's army had to get across the sea to Lanka. Big problem. So they built a bridge using stones that were blessed with Rama's name, and incredibly, the stones didn't sink. For centuries, this was seen as a straight-up miracle, a story of pure divine power. And that's really the core question, isn't it? It's a question that kind of forces us to look beyond the legend and start searching for a scientific answer. So, where do we even begin an investigation like that? Well, it makes the most sense to start with the star of the show, the stone itself. So our first clue takes us into the world of geology, because it turns out the whole idea of a floating stone isn't a fantasy at all. It's a very specific and very real kind of rock. Let me introduce you to pumice. This is a volcanic rock, born from incredible heat and pressure. When a volcano erupts and ejects this super hot lava, it cools down so incredibly fast that gas bubbles get trapped inside. It basically flash freezes the rock while it's still full of all these tiny pockets of air. The easiest way to picture its internal structure is to think of a honeycomb. It's just riddled with all these tiny sealed air pockets. You could even call it a rock sponge. And all of that trapped air, that's the whole secret. And here's where the science just makes perfect sense. A typical rock, is dense. It's much, much denser than water, so it sinks. Every time. But pumice, because of all that trapped air, has an overall density that's actually less than water. So it's not magic, it's just physics. Pumice floats. Okay, so the builders had the perfect material. But let's be real. Finding floating rocks is one thing. Building a stable 30-kilometer-long bridge that an entire army can cross, that's a monumental engineering challenge. So how in the world did they pull that off? Well, that brings us to our second clue, the engineering blueprint. That really is the puzzle, isn't it? I mean, if you just throw a bunch of floating rocks in the ocean, they're just going to drift away with the current. This wasn't just about the material. It was about designing a structure that could actually withstand the power of the sea. To solve a puzzle on this kind of scale, the builders needed more than just the right rocks. They needed an incredible plan and a truly monumental amount of effort. And here's where the genius of the plan really shows. The engineers likely weren't building up from the deep ocean floor. No, their first step was to find a natural, shallow underwater ridge that was already there and use it as a foundation. Then they started piling the buoyant pumice stones on top of it, building it up past the waterline. And finally, the crucial step. They had to lock it all down, maybe using strong plant fibers or by wedging the stones into coral to create a solid, stable causeway that people could actually walk on. An underwater ridge, you say? That's a pretty bold claim. It sounds almost too convenient. But our investigation has one final, decisive piece of evidence. And it comes from a tool the ancient engineers could never have even dreamed of. So let's pull our view back, way, way back. What can our modern technology show us all the way from orbit? And there it is. Wow, this is what NASA satellites see. A clear, distinct chain of limestone shoals connecting India and Sri Lanka. And just look at that data. The water along this line is incredibly shallow, only about 1 to 10 meters deep. This isn't deep ocean at all. It's a pre-existing natural ridge. It was the perfect foundation, just sitting there, waiting for an ambitious engineering project. So let's recap. We've got the material, we've got the brilliant engineering plan, and now we have satellite proof of the foundation. I think it's time we put it all together and deliver the verdict. When you put the two stories side by side, it's really striking. On one side, you have the legend, a pure miracle, with stones magically floating over a deep ocean. But on the other, you have a story that is, honestly, just as awe-inspiring, an engineering masterpiece, using a deep understanding of natural materials and geography to do something that seemed impossible. So, in the end, the story of Ram Setu probably isn't a choice between myth and reality. It's more like the place where they meet. It's a powerful legend that was likely born from a very real geological feature combined with a truly breathtaking feat of ancient engineering. And this leaves us with a really fascinating thought to end on. If the incredible legend of a floating bridge turns out to have a solid basis in science and engineering, well, it makes you wonder, doesn't it? What other ancient myths and legends are out there, just waiting for us to uncover the incredible true story hidden inside?